Okay, how this is going to be our presentation for the class. We're going to do this presentation over delivery robots. For the first part, I have the presentation, and we looked at to see what we would decide to go with, and we decided to go on delivery services because they are an ever-expanding business opportunity, which creates a ripe environment for intervention and technology development. Currently, the profits for the delivery industry for the U.S. alone amount up to 23 billion, and worldwide it counts up to 82 billion. These profits are estimated to reach 200 billion by the year 2025. So with such a large market and a growing market, it would seem reasonable that people start developing technologies and wanting to break into this market. So we thought the best way to break into the market would be through drone usage, which is already starting to see some people push towards into that. One of the ways that people use delivery services is through online and restaurant purchases, which are both growing, but so far it seems that online is growing slightly faster than restaurant purchases, which we'll show on the next slide through a graph. We believe that the reason to use robots or drones would be because they would provide a cheap and effective way to use delivery. And this delivery process would be useful for restaurants, postal services, pharmacies, grocery stores, and many more. All right, as you can see here, what I stated before, we have a graph that shows current revenue trends from back to 2017 up to 2024. And as you can, I don't know if you can see, you can barely see that it seems the growth rate for the platform to consumer, which is online ordering, is growing slightly faster than restaurant to consumer delivery. And that's why we think that drones will help impact the market, because it'd be easier to send a request in through to the people and put it through a drone instead of the restaurant themselves ordering it, because we believe most drone services will be through a third party. So far there have been a few comparable products. The biggest product would obviously probably be Amazon, who announced back in about 2012 for their first that they're going to start using drones to deliver some of their packages. Other notable ones are UPS, which just got FAA license and permission to drone usage, which was more than what I believe it was Google tried to get it, and they didn't get as much permission as the UPS did to use it. But currently, there's a lot of issues that go with drone usage and for most areas because of the hazards it can cause and with flying. So it's very restricted to just rural areas where there's not a lot of people, and so far it's only been in 8 states, and it's been kind of in a testing phase to see how it runs. For Amazon and UPS, they've mainly been using flying drones, but there is a company called Starship Technologies who have been investing more in land drones that will drive around, and they've been pairing up with companies like DoorDash, Postmates, Starbucks, and Dunkin' to deliver their products while going on the ground, which requires, so far from we've researched, less restriction than aerial drones. And they're also able to carry more than what an aerial drone can. So far, the ones we've seen can carry up to 22 pounds. And as we said, all of these, even with the Starship Technologies land drones, they've all been kind of trial runs so far in lower populated areas and on college campuses such as George Mason University. And one of the reasons they've used college campuses is probably because there's a lot of younger people that are more familiar with technology, and it's easier to get the drone going around in like a confined campus area to see how it moves around the buildings and the people without causing too much of a hazard with cars and other vehicles.
So moving on to the technological functions that will be required for our model. First of all, we're going to dive into the data analytics portion of it. So data analytics will play a really big role in our model because it can be used to provide feedback on things like order status and also sensor data that is needed for autonomous driving, as this is going to be an autonomous vehicle. So algorithms and optimization models will be employed in order to achieve full automation, and real-time order status will be able to be flowing through the system at each point of the transaction. And then going back to the sensory data, this is going to be things like radar, lidar, computer vision, sonar, and GPS. And the outputs from these sensors will provide information that will help the vehicle to navigate its path and avoid obstacles and read things like road signs. So this data is going to be collected, offloaded, stored, and interpreted, and the best way to do that would be through the cloud. So now onto the artificial intelligence portion. A big part of our model will be the natural language understanding capabilities of it, because it is a user interface type robot / autonomous vehicle. So natural language understanding involves natural language processing and natural language generation. So natural language processing is the act of the computer understanding what the human is trying to say, whereas generation is the response from the computer to the human, so the response back. And our model would be built similar to that of the smart speakers you see on the market today, like Alexa or the Echo Dot or Amazon Fire. So when you ask Alexa, what's the weather going to be like today? What happens is the device records your voice, and then the recording is sent over the internet to a cloud-based server called Amazon's Alexa Voice Services. And on this server, it processes the recording into commands it understands, and then the system sends the relevant output back to your device in the form of an audio file, and then you hear Alexa's response saying the weather is going to be nice today. So this requires a constant internet connection. And with our model being so mobile, the internet connection would need to come from something like a 3G or 5G source. And then every time a mistake is made in the process of this natural language understanding, a feedback model needs to be implemented so that the errors can then be reduced, because it uses machine learning to improve. So there would be a bit of a trial period with our model as the machine learns and receives feedback with that. So then also another element to this natural language understanding is question and answering. And question and answering is a very complex task, and it requires the ability to understand the NLU and reason it over relevant context, providing then an answer based on the information was provided. So you're going to need to use information retrieval and extraction techniques to create what is known as a knowledge base. And this knowledge base would have a logic-based query pulling the information from it, ultimately functioning as a chatbot through those processes. And once again, this also uses reinforcement or machine learning. And then the last element to NLU is voice recognition. And in order to build good voice recognition, the artificial intelligence needs to be able to handle challenges like accents, background noise, and the rate of the user's speech. So algorithms for verbal, linguistic, and acoustic modeling are used to create this voice recognition software. Our robot would need to be able to understand many different types of accents and slang, because the different types and diverse types of people that are going to be using this delivery robot ranges across all nationalities and ages. So our voice recognition software really has to be top of the line in our model. And then another aspect of AI that isn't NLU but needs to be in our model is image processing, because we plan to use QR codes as the mode of identification for when someone receives a delivery. They can then scan their QR code on the device, on the robot, in order for them to be able to receive the delivery. So that will require some image processing there to transmit the information.
Okay, so our delivery robot will be designed essentially as a compact autonomous vehicle, and the development of a fully autonomous vehicle requires the interaction of several systems that essentially enable the vehicle to sense and understand the environment around it and safely navigate through that environment. So some of these systems include localization and mapping systems, which will allow the vehicle to pinpoint its location within its environment. Perception systems, which are basically like sensors, video cameras that are attached to the vehicle that can perceive signals from other objects in the environment. Prediction and planning systems, which use data analysis techniques to forecast where objects such as other vehicles and pedestrians will be moving in the near future and plan the best route for the vehicle to take. Control systems, which basically maintain the physical control over the planned driving trajectories of the vehicle using actuators. Coordination systems, which allow the vehicle to communicate effectively with other vehicles in its sensor range, as well as information clouds to stay updated on changing road conditions and changing weather conditions, etc. And then an external human-machine interaction system, which allows the vehicle to effectively communicate with a human operator if needed. All these systems will ultimately be overseen by a powerful computer operational system, which is essentially like the brain of the vehicle. So the delivery robot itself will be operated by an artificially intelligent brain that will maintain control over several functions, including the multiple types of sensors that are able to collect and transmit data from the ever-changing environment around it, a computer vision program which can gather this information collected by the sensors and use it to perceive the surrounding environment, predictive and decision-making algorithms which will utilize the data analysis techniques to determine the safest and most efficient route for the robot to take, actuators and actuator valves, which are the physical controls of the vehicle, so they take care of the physical operations of the robot itself, such as acceleration, deceleration, and steering, and an effective user interface that is user-friendly and will enable the robot to easily communicate with its human customers. Go.
Security is a very important aspect for us in our delivery robots. And three aspects that we're going to cover in this presentation will be theft, cybersecurity, and legal risk. Theft. Our delivery robots are designed to discourage other people from stealing it. And some of the features that we have is locked lid. The lid that the robot have can only be opened through the app that the original customer had. The second feature would be, since the robots have cameras, those cameras not only facilitate navigation but also security. So let's say somebody's trying to steal this robot, the robot can take pictures of the violator and send it directly to the company. So in real time, the company can keep track of what's actually going on. The third will be an alarm system. So now let's give the scenario that somebody wants to lift the robot out of the ground. Well, the robot will have a very loud alarm sound that can alert others what's going on. And also, by having a two-way speaker system, the robot can actually speak directly to the violators. Well, a representative from X company will be able to talk to the violator directly through to this system. And let's say if somebody actually managed to steal our delivery robot, then the robot has a tracking device, so the company will be able to know where is that robot located. Moving on, we will be talking about cybersecurity. So data privacy is a constant concern for businesses and customers. Therefore, we want to cover our bases with this new delivery robot in order to address any issues related not only to data privacy, but also in cyber attacks in general. So essentially, robots, they have sensors, and those sensors can leak important information from the customer or the company that can be hacked easily. So what we're gonna talk about is that some of the points that we can use in order to mitigate this impact. In order to avoid this impact. So the first one is we're going to establish a framework of security, which means that within the robot configuration, a company can conduct tests of servers, firewalls, routers, and applications. Additionally, by performing a series of continuous reviews and data analysis, the information that is received by the robot can be identified if it is authentic, authorized, and valid. In that way, the company can keep track of the information and will be able to secure the product. Additionally, in order to secure the credentials during the robotics section, we will be using the lightweight directory access protocol and the single sign-on. This will allow to protect the digital identity and access to it. Hacking is also a very important concern because, once again, because of the sensors. But one way that we can prevent the hacking to our delivery robots will be ensuring that communication through cryptographic use, which means that any communication to any endpoint of the robot will be encrypted. Moving on with legal risks. Okay, legal considerations must be taken into account in order to respect and protect pedestrian safety. I was reading an article that was written by two important attorneys from a law firm that says the legal considerations that companies must be taking into account are civil liability, privacy and data protection, and regulatory concerns regarding traffic and motor vehicle laws. And well, it's a little bit fussy still because the traditional liability frameworks are not sufficient in order to provide solutions to potential problems that may arise from accidents or damage caused by these robots because of the level of autonomy that they have. It's not really a human, it's just a device. However, according to the civil liability law, the delivery robot will be liable the company that controls the robot will be liable in the case of an accident. So we understand that in this case, the designer or the manufacturer will be also held accountable if the delivery robot injures a pedestrian or damaged property under the theory of a strict product liability, which means that if this accident happened because of defect, error, or a bad design of the robot. Now moving on with the traffic and motor. It's okay.
My bad.
Now moving on with the traffic and motor vehicle laws. So what happened is that one is still very not clear enough because there are states that prohibit motor vehicles to go to sidewalks, and robots are still considered like that. However, there are still, as of today, 8 states in the United States have given the approval for robots to mobilize in sidewalks. However, they have provided some regulations to it. First, the robots must yield to pedestrians and bicycles. They can only cross the street at crosswalks. They cannot travel more than 6 miles per hour. And the company that owns the delivery robot must have an insurance policy, and they have to have at least $100,000 in liability. Okay, so after evaluating the various subjects pertaining to the design of our model, we have identified the following pros and cons. So the pros will be delivery of any product. This is great because this will enhance the effectiveness and efficiency of a business. Time management, it will be quicker. The customer will have a better experience as well. There will be savings because of labor and increased sales. People will be able to buy more things because they know they can access to it faster. It is a convenience to the customer. So let's say you're now be able to go ahead and buy a pair of shoes at that right moment. You can have them delivered to your house immediately, and that will be more comfortable and you're willing to pay more. Additionally, these robots, since they sensor and they receive a lot of information, we will have the opportunity to sell data collected to outside parties, but of course we understand that that depends of a state and privacy laws. And it will be environmental friendly. In the cons, we might need to outsource AI and VA services to people that have the expertise. We understand that also these delivery robots are very expensive, but it is worth the investment. Job losses. It is a critical aspect because we understand that a lot of people have the jobs of delivery, but they have it as a part-time and not as a long-term goal. So that's why, although it is a cons, we believe that that will actually be a potential improvement in businesses. It's a safety hazard. Although we are trying to get this model as good as we can, we also understand that there are risks that are outside our boundaries. And data breach, cyber attacks are still a concern, an ongoing concern, but we also believe that the model that we have created will be able to mitigate that and avoid that kind of attacks. The legal risk, we understand that we also have to adjust based on the state that these delivery robots operate and the delivery size. Based on the size and the weight that these robots can carry, there are not many things that we will be able to deliver to the customer, but the idea is to deliver convenience products that are just quick enough for the customer to be happy. And this was our presentation. I hope you like it.